And then for number 9, okay.
Oh, this is what I was telling you about how much of a pain PChem is. Because, like, you're given a scale,
Mm-hmm.
and that's the thing is every scale is different. So you're like, so every scale is a little bit different, but there's a standard deviation that they've discovered with all the scales that they manufacture. So you have to discover how accurate your individual scale is because they'll assign you a scale at the beginning of the semester. So this is literally what you do is you find the 95% confidence interval.
Uh-huh.
Like you find the margin of error of a 95%, like 95% confidence, and then you have to apply those calculations into everything you do whenever you weigh anything with that scale. And that's just one instrument. Like you have pipettes, you have tubes, you have so many like thermometers and stuff. Like you have so many different things, and you have to figure out the margin of error for all of these different instruments, which you're going to get different margins of error for all of them.
Yeah.
And then when you're trying to figure out, you have to take into consideration the margin of errors and how many significant figures you carry over. So yeah, that's PChem is the reason why I decided to go into molecular biology instead of instead of biochem. That
Oh.
was so brutal.
Yeah, that does not sound fun at all.
Yes, luckily this is just one single example, so this is easy.
Okay. So, it looks like this is a different. Sorry, I'm trying to compare the the reading, the lesson 15 reading questions to this one. It doesn't look like this is question 9 is the same. Okay, so I'll just read this.
So first thing, what's it asking for?
So it's asking for um how large should n be so that 95% of the confidence interval for mu has a margin of error of 0.0001.
Yes, so we're looking for an n here. And in this instance, so we have a mu.
We totally have a formula for this. So
Exactly.
it would be, so if we're trying to get n, hold on, where is that? Oh, okay, so it'd be sigma times z score over m2. Oh. This is the same one. Okay, so this is the same one. So I got 38,416.
That's what I got.
Read.
Okay, is question 10 the same?
Yes.
Okay, what'd you get?
And I got A. Wait, sorry. So A on this one is different for A on that one. So I got D.
D. So mu is 1250. Alternate hypothesis is mu is less than 1250.
Yes.
Okay, that's what I got too.
Sweet.
Okay, this is definition. Statistical test of hypothesis. We say we reject the null hypothesis when.
P-value is less than A.
Perfect. Okay, group of statistics students want to determine if students in some apartment buildings get better grades than students in other apartments. They collect GPAs from anonymous random sample size of 15 of the 4 different apartment buildings. The data for each apartment building is bell-shaped with no outliers, and the sample variances are nearly equal. So sample size is small, but the data is bell-shaped and the variances are equal. So can we use ANOVA here?
Yes.
Okay. And what is the definition of variances not being equal? Or I guess what's the standard we're using to say that variances are equal?
The standard. Oh. Are you talking about like when the the smallest variance has to be like 1/4 of the size of the largest for them to be equal? Is that what you're referring to?
Yes, but you had a dyslexic moment.
The largest variance has to be can be 1/4 of the smallest.
How could the largest be a fourth of the smallest? That would make it the smallest.
Like times it or something.
You're really close, but
Um,
if the smallest variance is 1/4 the size of the largest,
yeah.
that puts us right on the cusp, and then we're in unknown territory. The rule of thumb is the smallest should be less than 4 times the largest.
For them to be
So,
equal?
yeah. So you're pretty much right. It's just that you're using equal to rather than less than, and
Uh,
that puts you right on the cusp. So let's say we had the smallest variance was 2 and the smallest variance was 2, largest variance was 8. I
mhm.
honestly wouldn't know what to do in that situation because it's
Uh,
exactly 4 times larger.
okay.
But if we had 2 and the largest was 7, then we're good to go.
Okay. That makes sense.
So you're totally right. It's just that little nitpicky stuff, and it's the nitpicky stuff that freaking nails you on the tests.
Yes, they definitely like to trick you on these. Okay, let's see.
Okay.
So this I got committed a type 1 error.
Okay. What is a type 1 error?
Um, when you charge an innocent man.
So the null hypothesis is innocent until proven guilty. If
Yes.
you charge them as guilty when they were innocent, yes, that is a type 1 error.
Oh yeah.
So whatever helps you remember. Okay, going along with errors, what about question 14? Do you remember the correlation between type 1 and type 2 and why we decided that
Yes.
0.05 is kind of the standard we use for alpha?
Yeah, so when you try and decrease a type 1 error, you'll increase the type 2 error.
Yeah, and we've discovered that 0.05 is kind of the sweet spot where 1 in 20 studies is going to commit a type 1 error, but it also means that our type 2 errors, we're not committing a ton of those. So
Yeah.
it's kind of that little sweet spot.
Yeah. Okay.
Okay, question 15. What'd you get?
So I got reject the null hypothesis. Is
Okay.
that what you got?
What did you get
My
for
T-score, I got 90. So I'm just looking at my notes, so I'm not even sure if yeah, so I got 90 for my T-score.
okay. Is there okay, so tell me what does a t-score of 90 mean?
Ooh. Um, well, it's a really large t-score.
Yes, it's huge. So
Um,
it's way out there. So
yeah,
if you have a t-score that's that big, what's your p-value going to be like?
super, super, super like small,
Hmm.
like
So
point zero 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 zero.
yeah, so provided find did I do this today? I'm double checking. Because I got a different answer than you. And you totally understand the concept, so it must be a calculation thing. And I'm just thinking a t score of 20 is huge, but we've had t scores pretty high like that, so I just want to double check. Okay,
Yeah.
so yeah, I found my calculations. Okay, so we've got a mu of 1.5, an x of 1.53, sigma is actually given in this case. So here's a question. Um, okay, and I'm not even sure if this is a well-worded question, so I apologize if it's just confusing. What's wrong with the t-score?
With 90
No.
or in
What's
general?
wrong with what's wrong with the t-score?
Um, it, I don't know. Um,
When do we use t-score?
we use t-score when do we use t-score?
There's only
Oh,
one specific instance where we use t-score. Everything else we're either using the no wait. There's a few instances where we're using the t-score. Then we also have the f-score and the z-score. So when do we use the t-score?
oh, it is when something is isn't it when, oh, it's when mu is unknown.
No.
Or is it,
It is when something is unknown.
because we're given the sample mean, we're given the standard deviation, or the sigma. Um, so it's mu, right?
No, because there's a lot of times where we need to create a 95% confidence interval and we're given the sigma. So we're estimating mu, which is fine.
Oh, is it when we're doing like degrees of freedom?
What
When
does
we're doing the sample size? No, because we use sample size for.
so
Oh,
oh, you got
when
it?
sample size is unknown.
Nope, we know the sample size. And if the sample size is unknown, well, how could a sample size be unknown? We're taking the samples, so we would know how many we take.
Is it when the standard deviation is unknown?
There you go. Last one. So when,
Dang.
so when sigma is unknown and we have to estimate it, we estimate the standard deviation. And when we estimate the standard deviation, we then have to use the t distribution. And when we're using the t distribution, we need to include our degrees of freedom to kind of alter the graph so that we get a better representation of what our of what the true distribution is. Because sample sizes of 3 is going to be more off course than sample sizes of 100.
Okay.
So in this case, we got sigma, which means that it's just a straight up good old t-score.
Mm-hmm.
And what was your calculation for your t-score?
So I put down 1.53 over 0.17 divided by the square root of 100.
You're really close.
Did I miss something?
Yes.
Um,
Because we haven't had to deal with it for a while.
let's see. So t-score is something. Wait for it. Oh, shoot. So it's x bar minus mu over standard deviation divided by square root of n.
Exactly. So that means the top number is supposed to be 1.53 minus 1.5, or the top number is 0.03 divided by those numbers. You had 1.53 divided by those numbers. So the t-score that you got was way bigger because the top number was way bigger than it should have been.
Big. Dang, it does say the mean nicotine content. I totally missed that. Okay, so so it's gonna be $1.765.
Okay, that's what I got. So with z-scores, our sample size doesn't matter for the applet. So what's the magic number we're looking for with the z-score if we have a 95% confidence interval or 95% confidence?
We're looking at the p-value.
Yeah, and we can put that in the applet, but since this is a z-score, we already know what z-score we're looking for. So what's the z-score that we're looking for? We need a z-score higher than what if our alpha is 0.05?
I mean, we're looking for anything larger than the alpha, right?
So,
or sorry, anything smaller than the alpha we want.
So what does this t-score measure?
The probability of, wait a second.
The t-score helps us calculate the probability with the applet, but what does the z-score and t-score itself, what does it measure?
It measures like your deviation?
Yes, in what way?
In a way.
If I were to say that the t-score is 2, what does that tell you about where I lie on the curve?
Doesn't it tell us like about our mean as well?
Not necessarily. Well, it tells us how we relate to the mean.
Okay.
So if I were to say that I had a t-score of 2, a z-score of 2 on my ACTs, what does that tell you about how I compare to the mean?
That it's 2, I want to say standard deviations away from the mean.
Exactly.
Okay.
So the t and z score just measure how many standard deviations you are away.
Okay.
How many standard deviations do you need to be away in a normally distributed curve? So we're using z-score. How many standard deviations away do you need to be in the 95th percentile?
2.
That's what we started the semester with. The number got changed a little bit.
It changed to it was 1.96.
Yes.
Okay.
How does our z-score compare to 1.96?
That's like, how do they compare?
Yeah.
Um, like, well, whenever we have like a 95% confidence interval, 1.96 will always be our z-score.
Yes. So our z-score is less than 1.96, which
Yes.
means our p-value is going to be greater than 0.05. So if our p-value is greater than 0.05,
Then we fail to reject the null.
exactly.
Okay. Dang. Okay. Okay, so the next one. Okay, so 13 I got. Independent samples.
Okay, why not ANOVA?
So I think when we talked about this last time, I was confused on. I asked you like, what's the difference between like an independent sample and you know those other ones. So let me reread this. You would like to look at the mean number of hours. So there's going to be 2 samples,
Mhm.
male and female. So that's why we wouldn't do ANOVA because that's 3 or more.
Perfect.
And so it would be a but they're not paired.
Yeah. There's nothing connecting the male students to the female students. You're totally right. Independent sample t-test.
Oh, okay. Cool.
Okay. Just wanted to quiz you on ANOVA real quick. Okay. Question 17. What'd you get?
I got dependent samples.
There's 2 answers for that. So which one did you choose?
That is a good question. I put D, so I put which is dependent sampling if you select a brother so as to compare his academic achievement to his sister. You must include the sister in the study.
Yeah. So the fact is, knowing who is on one sample can tell you who can be in the second sample. So, for example, like let's say you had a list of names, you didn't know the people, but let's just say, just sheer coincidence, everybody had a unique last name. So it wasn't like there was like 27 Nielsen's or Nguyen's if you have a bunch of South Koreans. Let's just say everybody had a unique last name. And you're going through the guys and then you're going through the girls, and Yeah, you're recognizing the same last names, and you're like, oh, okay. It looks like Murdoch is going to be compared to Murdoch. Samson is going to be compared to Samson. So you automatically know how they're going to be compared, and so that's dependent sampling.
Okay. Yeah, that makes sense. It's kind of like, yeah, I always think like couples or like siblings or anything like that, something that would relate them to each other.
Yeah, exactly. Okay. Question 18.
I got confidence interval for mu when sigma is known.
Okay.
Is that not what you got?
Oh, wait, say that again.
Confidence interval for mu when sigma is known.
Okay. So we're definitely doing a confidence interval. The researcher would like to construct a 95% confidence interval. But if you pull up the spreadsheet, we have 20 samples. Yeah, so 20 samples of the dissolved organic carbon. So we're trying to estimate the mu. We can calculate out the average, and we know n because it's just 20. We count 20. But where is sigma?
Oh, sigma is not known.
Exactly.
Okay, so it's confidence interval for mu when sigma is unknown.
Yes, that's why I'm trying to drill into your head using sigma and mu
Yeah, and not
because
standard deviation and
yes, because
that as well.
we can always calculate standard deviation. We can
Yeah,
always estimate standard deviation, but sigma has to be given to us.
yeah.
Sigma
Okay,
we sigma we cannot calculate.
okay. Alrighty.
And it's just so much easier to say sigma and mu as opposed to standard
Standard
deviation
deviation.
of the sample versus standard deviation of the
Yeah,
population.
totally
I
agree.
just like that shorthand. Okay, question 19.
So I got 11.168 and 15.217.
Okay, perfect. I'm not sure if it is different on the homework. There's a third question there for the margin of error. Did you calculate that?
Um, Wait, sorry, what was this? What was that?
So you skipped question 19. I'm not sure if that wasn't on the homework, but it was
Oh,
asking about margin of error, which you need to calculate anyway to get the lower and upper bounds.
yeah.
I dropped a drink on the way out. Those are the things that you can read with.
Let's see, did I not do that?
Okay, well, let's look at it this way because it may pop
Okay.
up on the test this way. Let's say you've got your upper and your lower bound. How would you calculate the margin of error from that? Because that was a question on one of the previous homeworks.
Yes, it was. We did it. Didn't we divide it by 4 or something like that?
Close. What is not in variables or anything, but just in broad terms in English? What is a confidence interval?
The range of data that we have.
So a range of data.
Mhm.
What's the center point?
The mean.
The mean.
We
How
divide by
far
2.
exactly?
Okay, so we divide the largest or the highest interval by 2.
You take the larger minus the smaller, because that will give you the range that you're talking about, and then divide by 2.
Okay, I need to write that down. I never find my pen whenever I need to write something. Okay, got it. Okay.
doing on the cabinet, right?
Okay, so the margin of error, and that will give us the margin of error. Okay. And so I got 2.025.
Okay, that's what I got. Okay, next three questions. Used, Hummers, NY, and LA. Can we pull this up real quick? Okay, so a random sample of Hummers for LA and New York were taken. Listings above. Want to know if there's a difference in the mean list pricing. Okay, so of the four confidence intervals listed below, which one is appropriate for this situation?
Okay, so let's see. So I got confidence interval for the difference of means using independent samples.
Exactly. How would that look like in mathematical form? So the null hypothesis and alternate hypothesis, what would that look like if you're using math?
So the null would be D bar using independent samples. Using
So when we're using D bar and then in the null hypothesis, what do we always set it equal to?
0.
Yes. So that's just an annoying mathematical way of saying that there is no difference between the two. So it's basically the null hypothesis is group 1 is equal to group 2.
Okay.
Statisticians like to describe things in math and make things a little more complicated, so they say the difference between the two is equal to 0. So just wanted to make sure you understood that, because you're going to see both popping up on the test. Confidence interval for the difference of means, and D bar is equal to 0. Okay. Moving on. Let me calculate this out real quick, because it sounds like you're working ahead of me. Dang. That is a lot of data.
Whatever you have.
Okay. So, Mars, Los Angeles, and New York starts there. Okay. Get rid of that.
Say it again. What it is. Well, yeah, that.
Which the black pen?
But there.
Are you keeping it for the timer now?
I just put it in the cabinet truck. Then they wanted it.
You bought yours? Are we taking up like this?
It'll fit nicely on top of the one.
Things were getting sure. those new guys, put them up for some of this fake stuff. You see what I mean?
What kind of thing?
The plastic one. So did you talk to people?
Who?
How did it?
Yeah.
What did it say? Los Angeles is group 1. Okay.
Driving all day Monday, Tuesday, Wednesday.
No, not
Wednesday,
that.
Oh, then you go back.
Yeah.
Still working on it?
Yeah, give me a second.
No, you're good. I just didn't want you to be like waiting for me or something like that. Like, oh, what's up?
Wait a minute.
Wash down. Clear up. Wash. Things will finish. Start cleaning the cupboard.
Or, yeah. Yeah. Good.
Something you usually take off before.
Well, my concern is I don't know how fast I go.
Town road to it.
Oh, Georgia.
Okay. So what did you get for 23?
So I got negative 423.
Okay, and you're upper bound?
I got 5,417.
Okay.
Is that what you got?
No. I'm actually trying to figure out how to solve this because this is interesting and I don't know if it's super or what. But actually, well, they give us weird information.
Let's see.
Because the thing is, for this, we are doing a confidence interval of the difference of means. So that means we need to find the difference between each of the samples they gave us. Then we need to figure out the average of the differences. And that becomes, our D bar. Problem lies in that we need to find the standard deviation for the differences. But we are given a different amount of cars between Los Angeles and New York.
Yeah.
So I'm not sure which, because the point is you're supposed to find,
Actually, the freeway.
that'd be, is that paired? These are independent samples. So since they're not paired, we probably just need to know
Did you say that was Tennessee?
Yeah.
Oh.
I wish I still had my thing.
No, I was overthinking this. This one, if it was equal numbers, if there were equal numbers of trucks, then we could actually get the standard deviation of the difference. But because they're not equal numbers, we need to use quantitative inference procedures. So that was my problem.
Yeah, I always just plug mine in.
Yeah. Okay, that's what I was doing wrong. Okay, give me another second.
You're good.
Oh, it's behind.
Yeah.
Yeah.
Yeah, I just plugged it into the 2-sample t-test and it came right up.
Yeah, and technically if they gave us the same sample size for both groups, we actually wouldn't need the spreadsheet. We could calculate it out. But because they're not equal numbers, yeah, we need the spreadsheet to do the special calculations for us.
Yeah.
Okay, so let me just double check real quick. So what'd you get for the lower bound?
So I got negative 423.
Okay. And the upper?
I got 5,417.
Okay, yeah, that's what I got you.
Cool.
Exercised density. Let's get out of these unneeded ones now. Okay. So exercise bone density. Let's see how many groups we're looking at. So we got control, table editing, control, low jump, high jump. Okay, so we have 3 different groups. What does that tell you immediately? What type of test are we going to run?
No.
Perfect. Okay, and since this is ANOVA, and we cannot do ANOVAs, this is just a plug and chug. So let me put them in the spreadsheet real quick and we'll compare, make sure we got the same things.
Okay.
First question, test statistic. I got 7.978.
Yep, that's what I got.
Okay, perfect.
And then the p-value, I got 0.002.
That's what I got. So with a significance of 0.5, what are we? So what's our conclusion?
There is significant evidence to conclude that the mean bone density between all the groups are different.
Close.
I was gonna say, wait, that doesn't. It's there's a significant.
Remember,
Yes, the
ANOVAs
one,
are
right?
useless. Yes.
So there is significant evidence to conclude that the mean bone density of at least one of the
Yes.
groups is different.
There you go. Yeah. Just remember, ANOVAs are useless. They
Yeah.
just tell you that.
They're useless.
Yeah. No, they tell you that at least one, so you don't know if it's one or two in this case, or if you have more numbers, it can be even more. You don't know if it's one or two, and you don't even know which ones they are. So just remember, ANOVAs are useless. That's how you find out that's how you do hypothesis conclusions with ANOVAs. Is just think of the most useless conclusion you can come to, and that will be the answer for the ANOVA.
That's it. It's hilarious.
There's sufficient evidence to conclude the mean bone density of at least one of these groups is different than the mean bone density of at least one other. Seriously, that's so useless, but that's what ANOVAs do for us. Okay. Okay, so close out bone density. Open up direct flight cost. Days and 14 days in advance. Okay, so what type of hypothesis are we testing for here?
Dependent samples?
Yes. Because knowing about one sample group is going to tell you about the second sample group. So if you know that there are 3 samples that are flying to London, you know that the 14-day sample group is going to have 3 flights going to London.
Yes.
Garage.
Okay.
Driving.
And this one is just 2. Open up this. Awesome. This one even has zeros, null data, so we get to delete cells to make sure we get the right calculations. More busy work.
Yeah, that was frustrating.
Okay, there we go. Test statistic, I got 0.837.
I got 1.685.
Okay. Oh, we are looking for a significance level of 0.1, not 0.05. Let me change that. We are saying that they are less than. Is that the null hypothesis that they're less than, not equal? Okay.
That's more like 12 hours to me.
But, that's why we'll just kind of put it by year.
Or 10 hours. You're going 70 miles an hour, but
Okay.
no stopping.
2 sample t-test for means. Oh, I was doing Okay, let's do paired samples. Sorry about that.
You're good.
We're just sitting down for nonsense, so might as well throw these in my food. I'd say this one is finished, we could seal it if you want. Do we, let's take, because we smart in the car.
Yeah.
Okay, there we go. Okay, what was your T-score again?
1.685.
Okay, that's what I got.
And my p-value, I got 0.096.
0.956.
We're going up to drop tomorrow. So where, do we have them?
We'll always go with that.
6. I got 7,
And there's some-
just due to rounding.
I don't
So
know.
0.957.
Oh. wait, sorry, what was it?
I got 0.957.
Okay, so,
Okay, air out. I mean, we just push the air out, let's push the air out. Not put like this.
oh. I see what you're saying. So I got point, huh.
I don't.
You got 0.097
Oh, I think so. No.
rounding?
0.0957.
Okay.
And strangely, this is a two-tailed test. So it's to see if there's a difference, not to see if they're cheaper. Okay. So that means our p-value is 0.0957. Our degree of significance is 0.1. What is our conclusion?
So I got there is insufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
So how does our p-value compare to our alpha?
So our p-value is less than our alpha.
And when our p-value is less than alpha, what do we do?
Reject the null.
And our null hypothesis is what?
Question. Null is, it's equal 0. So there is sufficient
evidence for what? There's two options with sufficient evidence in there.
to conclude that there is a
I think I write 3.
there's sufficient evidence to conclude that there is no difference in the mean tickets of cost of tickets purchased 14 days in advance.
What's the null hypothesis?
The null is
And then that was the one more. Do we do it?
d bar equals 0.
Which means that there's no difference, right?
Yes.
So with our p-value and our alpha, are we rejecting or failing to reject the null hypothesis?
We are rejecting the null.
So we have sufficient evidence of that the null is incorrect. So how are we phrasing that in words?
So there is sufficient evidence to conclude that there is a difference in the mean cost of tickets.
Perfect.
Okay. Those always trip me up. I'm not sure why.
You got to go through word by word.
Yeah. Okay. Let's see. I can submit.
Okay, so it looks like we missed what? I should tell you which one she missed down at the bottom because I had to go digging. So just one. So question 15.
Okay. Let's see.
And let's see. That one, I think we had different answers on that one, so it looks like you may have gotten that one right.
Huh.
That one was the cigarette one. Let me see if I can find my calculations for that again. Nope. Okay, let me do that one again real quick. See if it wasn't me. Because that one was, I have failed to reject the null hypothesis. I can't remember if that was just a slip of the finger or if I had my calculations wrong on that. So give me a second.
Okay.
Okay, so get rid of this. Okay, so we've got U of 1.5, mean of 1.53, sigma of 0.17, and an n of 100, meaning that the square root of n is. So we have got a one-tailed hypothesis. We are thinking that it is greater than 1.5. So we have sigma. We are using a z-score. Our z-score is 1.53. That's 1.5. Sigma divided by the square root of n. Oh, that got weird. Okay, try that one more time. 1.53. That's 1.5. Divided by sigma divided by 10. There's a t-score of 1.6. Just pull up the probability. Oh, dang it.
Okay. Not really heavy.
Okay. Just one more second.
Gotcha. Okay, so. I'll go out and do extract 1, 2.
Well, no, I'll get the stuff in and then we'll start.
Oh, that was the problem. I'm so
Well,
dumb.
no, I can figure it out.
If it is two-tailed, we would fail to reject the null hypothesis because if it's two-tailed, our p-value is 0.07. But if it's one-tailed, our p-value is 0.038. So that case is we reject the null hypothesis and say cigarettes actually have more than 1.5 milligrams of nicotine.
Sweet.
So have you submitted yet?
Yeah, so I submitted with reject the null and it was right. So,
Yeah, that's correct. I had failed to reject because I did the calculations wrong. So I'm just gonna have to go back and change that.
okay. All right. So next week are you gonna be on the road for Tuesday or
No, the plan is tomorrow through Sunday, so we'll go back to our Tuesday, Thursday next week.
okay. Well, be safe and
Okay.
don't fall asleep at the wheel or anything like that.
And hold on a second. Hey, Mom,
Uh-huh.
can you do me a favor?
Yeah.
My mom has been having a rough day just doing all this planning and stuff.
Sorry, I'm eating.
Oh,
Could you Could you tell my mom that I would make a good instructor? She really wants me to be a teacher.
He is awesome. Like, I would be failing this class if it wasn't for him. He's so patient and he just explains things really well. Yeah, we have
I
quite
can
the
always tell Ryan he should teach. Sorry, I'm eating.
No, you're fine.
Yes, he's a good boy.
Then I will see you on Tuesday. And if you come across any questions or some concepts or just aren't making sense, just shoot me a text. I'm going to have plenty of time text in the car when I shouldn't be.
Good luck on the test.
Yeah. And yeah, just remember, like we talked about for the last test, deep breathing, yoga breathing. Don't do that labored breathing that you were doing last time, like you're giving birth. Deep breath, yoga breathing, take a break when you need to. You got 4 hours to take the test, so you can just get up, get lunch, walk around, whatever.
Yeah.
And read every single word on the test because you got the concepts down. Just let Mr. Cook tricky questions.
Yeah. Ooh, I'll let you know how I do.
Now you're gonna rock it. This is pretty much the same as the last test, except for now, like, literally half the new material is just reading Excel spreadsheets.
Yeah, which is really easy. So
yeah, so you totally have this. So yeah,
cool.
If anything pops up, just shoot me a text. And yeah, if we need to have a late night Skype session when I'm in a hotel, then we can totally do that.
Cool.
If not, we can just talk through text and whatnot.
Okay.
We'll be able to answer most questions that way.
Okay.
Yeah, let me know how your settings going, and
Awesome.
We'll stay in touch.
Thanks. You're the best.
Okay, see you next week.
See ya.